For our warm-up today, we're practicing systems of equations. So we're finding where each of these lines intersect. So our very first one that we're looking at here, this is going to be a good choice for substitution. And we're going to be using that specific type of substitution that we learned that's called y equals y. So the reason it's good for that is because they're both in slope-intercept form and our y is isolated. So y is equal to y. So our first y, we're going to set it equal to negative x minus 7. And our second y, we're going to set it equal to 2x plus 2. Now we're going to simply solve for x because we've eliminated our y. So we're going to add x to both sides. And we have negative 7 is equal to 3x plus 2. Subtract 2 from both sides. And we have negative 9 is equal to 3x. Divide both sides by 3, and we have x is equal to negative 3. Now remember, that is half of our answer. Each answer is an ordered pair because we're looking for where those intersect. We're looking for that ordered pair where those two lines cross. Now that we know what our x is, we're going to simply substitute it into either the top or the bottom to solve for y. I'm going to go ahead and use the bottom one simply because there are less negatives. So y is equal to 2 times, and I now know that x is negative 3, so I'm going to replace that there, plus 2. Y is equal to negative 6 plus 2. Y is equal to negative 4. Now, if I plugged it in here, negative 3 is 3, and I would get 3 minus 7, which is also negative 4. So once again, it doesn't matter which one you pick. You just use which one is better for you. And then it is always a good idea to go ahead and check on Desmos that you're correct. So our first equation was y is equal to negative x minus 7. And as you can see, that is a slope of negative 1. And it has a y-intercept of negative 7. And our second one is y is equal to 2x plus 2. This one's going to have a positive slope and a y-intercept of 2, and it's going up 2 and 1 to the right. And then we're going to go ahead and click on that intersection. And as you can see, we did get that correct. They do intersect at negative 3, negative 4. Let's go ahead and look at the second one. The second one is also set up for substitution, and it's because one of them is y equals. So we're going to go ahead and rewrite our top equation. And when we hit our y, we're not going to write y. We're going to write what y is actually equal to. So 4x minus 2, we freeze, and we write what y is equal to in parentheses, 2x plus 10, and then we finish the rest of the equation is equal to 5. Now we're ready to go ahead and distribute that negative 2. So we have 4x, negative 2 times 2x is negative 4x. Negative 2 times 10 is negative 20 is equal to 5. And then we're going to go ahead and continue. So we are going to cancel this out here, and we have negative 20 is equal to 5. So our variables went away. So what does this mean? Well, what this means is that these lines, it's no solution. But when we have a no solution for a set of lines, it means that they are never going to cross. And so when we have a no solution, which means they're never going to cross, what that means is that we have a pair of parallel lines. And that means that they have the same slope, but they are have different y-intercepts. If we had a true answer, if we had negative 20 is equal to negative 20, then we know that they would be the exact same line. So let's go ahead and look at this on our Desmos graphing calculator. That way you can see what these lines look like when we do get a no solution, when our variable goes away. So we have 4x minus 2y is equal to 5. And we have y is equal to 2x plus 10. So as you can see, these are a set of parallel lines. Our first line has a y-intercept of negative 2.5, and our second one, of course, has a y-intercept of 10. And they both have the same slope. Let's zoom in so you can see the slope a little bit better. So to get from one good point to the next for our slope here, where's our good point? We're going to say we have a slope of 2. So we go up 2 and 1 to the right from one point to the next. So these two lines have no solution, but remember, when we see that as no solution for a system of equations, we don't say no solution. We need to tell you that they are indeed parallel lines.